All right, what's up, everybody? Good morning and welcome back to another weekly live stream from Scalar Learning, and we are continuing going through SAT problems from Khan Academy in the math section. And if you like what you see, if you're enjoying it and you're preparing for the upcoming SAT, which is a week from this Saturday, make sure to subscribe to the channel. Make sure to like the video if you like it, you found it helpful, and also leave a comment. I've already been getting great comments and questions about, hey, how did you do this, or can you explain that step a little bit more clearly? I love questions like that, and I will do my best to get back to you right away and give you an explanation. Thank you guys so much for those of you who have subscribed. And let me do a quick sound test and make sure we are good to go here. Audio's coming through. Yep. All right, let's do it. Let's jump right into it. All right, so we're doing linear and quadratic systems. And as always, I'm seeing these problems for the first time, which is always part of the fun. Let's do it. Negative 3y, so we got a system. Xy is a solution to the system of equations shown above. Which of the following are x coordinates of the solutions? All right, so here's the deal. Basically, we got a line. This one is a line, and this is a parabola. So I assume they're going to intersect like that. It doesn't matter really, the graph. All we got to do is find the solutions. So here's what I'm going to do. I'm going to do a little substitution. Let's see, is there any better way? Yeah, I think I'm just going to do a little substitution. So I am going to substitute in, let's see, y or x. I'm going to substitute in y. So I'm going to take this bottom equation and I'm going to isolate y. So it's going to be y. I'm going to move the 4x to the other side by adding it. I'm going to move the 2x squared to the other side by adding it, and a 3 like this. I'm going to take this and plug it in to the other equation as follows. Since y equals all of this, I'm going to take it and plug it in right there for y. So now we have negative 3 times 4x plus 2x squared plus 3 minus 4 equals 9x plus 2. Then I'm going to distribute this guy like this all the way here. We got negative 12x plus, that should be a minus because it's a negative 3 that's distributing. So minus 6x squared, right? Negative 3 times 2, negative 6. Minus 9 minus 4 equals 9x plus 2. Okay, let's combine these like terms. So now we get, I'm going to write up here, let's move this. We got negative 12x minus 6x squared minus 13 equals 9x plus 2. We're going to set everything equal to 0 so we can factor, hopefully. And I'm going to subtract 9x from both sides. I'm going to subtract 2 from both sides. And now we have, let's see, I'm going to put this term up front here. Negative 6x squared minus 9 and negative 9, negative 12 equal negative 21x. And then that becomes minus 15. Okay, equals 0. Now we're almost there. Now we can start factoring. First, I'm going to pull out a negative 3 out of everything. So I'm going to divide everything by negative 3, and this becomes 2x squared plus 7x plus 5 equals 0. Now let's see if we can factor this. So there's a way to do it. I think I can do kind of do this mentally. So I know that if I have a 2x squared as my first term, the first term is going to be 2x, and this one has got to be x. It's the only way we can 2x squared, really. And then, let's see, 5 and 1, the only way we can get, everything's positive now. Only way we can get 5 and 1, it's got to be 5 and 1. It's a prime number. And I set it up like this to see if this works, but this actually won't work, because this will give us 2 times 5, which is 10x, 1x, which would give us a middle term of 12x. That won't be good. So instead, these guys have to switch. So we need our 5 here and our 1 here. So why that works is because then if we redistribute it, we'd have 2x squared plus 2x plus 5x, which would give us our 7x plus 5. And everything, therefore, works out just like that, which means our solutions are x equals negative 1, right? Whatever value makes this go to 0. And negative 5 over 2, which is whatever value makes this go to 0. Those are our solutions. So it is B, negative 1, negative 5 over 2. Oops. Yes, it is correct. Sweet. Number 2. Same dealio, which are, except now they want the y coordinates of the solutions. So this is the same idea. We're going to solve the system, I think, using substitution. Let me think about it for a second. This is actually a circle, by the way. And this is a line. I'm just trying to see if there's any faster way that I can think of. I think we just got to do, yeah, we just got to do substitution. So the bottom one, it's going to be pretty easy. X minus 2y equals 5. To isolate x, so x equals, I'm going to add 2y to both sides like this. X equals 2y plus 5. And then I'm going to take that and I'm going to plug it into my top equation. And this is going to be good because we're solving for the y value, so we don't have to plug anything back in. We're going to be good to go. So now I'm going to replace that x with 2y plus 5. And that is squared, right? Just like we had x squared, now we have this value, quantity squared, equals 10. But we need to FOIL this. We can't just leave it like this, because this is actually 2y plus 5 times 2y plus 5. That's what this is. It's not just 4y squared plus 25. That would be a mistake. Now, let's FOIL this. So we get 4y squared plus 10y plus 10y plus 25 plus y squared equals 10. So these guys combine over here. These guys combine over here. So now we got 5y squared plus 20y plus 25 equals 10. Subtract 10 from both sides, right? Same as last one, we were setting this equal to 0. And now we got 5y squared plus 20y plus 15 equals 0. Divide everything by 5. We got y squared plus 4y, right? 20 divided by 5 is 4, plus 3. Boom. Now we can factor this very easily. This is a nice one to factor. Y and y. What multiplies to 3 and adds to 4? 3 and 1. And that's it. So our solutions now are whatever makes this quantity go to 0, which is negative 1. Whatever makes this quantity go to 0, which is negative 3. So y equals negative 1 and negative 3 right here. That's it. Sweet. Moving on. xy is the solution to the system of equations shown below. What is the product of the y coordinates of the solutions? Now we have to get the y values and then multiply them. All right, so I'm going to do the same thing with that bottom equation. I am going to set it, isolate x, negative 2y plus 8. And then I'm going to plug that in to this equation. This equals x, therefore let's replace the x with it down here. You know, we're doing this because we always want one variable in one equation in order to solve. That's why we have to substitute. Otherwise, we have infinite solutions, and that's not what we're looking for. You know, two variables in one equation. All right, so this whole quantity squared plus 4y squared equals 40. So let's FOIL this out. I'm going to do this one a little bit faster. I'm not going to write it out. I'm just going to kind of tell you. Remember, it's going to be negative 2y plus 8 times negative 2y plus 8. So negative 2y is multiplied, we get 4y squared. Negative 2y multiplies the 8, which is negative 16y. And we're going to get that twice. So I'm just going to skip to say negative 32y. And then 8 times 8, which is 64. Just trying to save a little time. These guys combine, so we got 8y squared minus 32y plus 64 equals 40. Subtract 40 from both sides, and we get, let's write it up here, 8y squared minus 32y plus 24 equals 0. Everything's divisible by 8, so divide everything by 8, and that 8 basically goes away. And now we got y squared minus 4y, 32 divided by 8 is 4, plus 3. Again, this is super nice to factor because we've got y and y, gives us our y squared. What multiplies to positive 3 adds to negative 4? That's a negative 1 and a negative 3. Therefore, my solutions for this are what makes this go to 0, which is 1. What makes this go to 0, which is 3. So y equals 1 and 3. But they want the product of those. So 1 times 3 is 3. So hopefully that is correct. Yes. All right, sweet. 2 more. Same dealio. I'm going to do the exact same as the last one. I'm going to isolate x, and plug it in. X plus y equals 3. X equals negative y plus 3. And I'm going to plug it into x squared plus y squared equals 9. Take this guy, plug it in over here. We now have negative y plus 3 squared plus y squared equals 9. This becomes y squared minus 6y, that's negative 3y, and negative 3y added together, plus 9, plus y squared equals 9. These guys combine to give us 2y squared minus 6y plus 9 equals 9. We subtract 9 from both sides. These both go away. So now we have 2y squared minus 6y equals 0. This is interesting. We don't FOIL it, or we don't factor it the exact same way. Now we can factor out a 2y, and you just have a y minus 3, like this, right? If we redistribute it, we get 2y squared minus 6y. That's how we know we've factored this correctly. And then what are the two values that make this go to 0? Well, when y equals 0 for this term, boom. And when y equals 3 for this term, boom. And that's it. Y equals 3 and 0. And they want the product again. Well, 0 times 3 is simply 0. So hopefully that is correct. And that seems to make sense, so I think that's right. Yes, one more. Now we got a graph problem. The graph at left shows the parabola negative, this guy. Okay, consider the following linear equation. Y equals negative 3x plus b. For some constant b, if one of these solutions to the system formed by the parabola and the linear equation is negative 4, 5, which of the following is the other solution? Okay, so this has got us thinking a little bit more. So here's what I'm thinking. I've got this equation, and I've got this equation. First of all, to solve for these guys, wait a minute, we could do a couple things here. This is interesting. Let me see. Wait a minute. This is easier than I thought, I think. First, we can solve for that b value, right? Okay, so here's what we can do. We can solve for that b value by plugging this coordinate in here. I was gonna do something, but I'm changing my mind. So plug this coordinate in. So negative 4 goes in for x, 5 goes in for y. So we got 5 equals negative 3 times negative 4 plus b. We can solve for b this way. Negative 3 times negative 4 is positive 12. Subtract 12, subtract 12, and we have b equals negative 7. Boom. So now this guy is just 3x minus 7. We have just solved for this. Now we do it just like we did before. The second equation is y equals negative x plus 4 squared plus 5. And we're just now setting these guys equal to each other. I mean, honestly, I could even graph this guy now, because I know where the y-intercept is here, and then it's kind of going up. Here's it's negative 1, 4. It's C. I can tell that just from graphing it. But I want to show the algebraic way. Let me just explain what I just figured out. Because I know this equation is negative 3x minus 7, I can make a graph here where I know the y-intercept is negative 7, and the slope is negative 3, which means it goes left 1, up 3, left 1, up 3, left 1, up 3, left 1, up 3. There's the other coordinate, right? Negative 4, 5. But just starting from here, I'm just like left 1, up 3, boom. There's the first intersection, which is negative 1, 4. You can do that. The algebraic way is we set these guys equal to each other. Negative 3x minus 7 equals negative x plus 4 squared plus 5. So let's carry this out. This becomes x squared plus 8x plus 16 plus 5, which is equals negative x squared minus 8x minus 16 plus 5. I just distributed everything. We still got negative 3x minus 7 over here. This becomes negative 11. Okay, and now I'm going to bring everything over to the left side. So add x squared, add 8x, add 11. Okay, and add x squared. So we get x squared plus 5x plus 4 equals 0. Factor it like this. X, what multiplies 4 adds to 5? Positive 1, positive 4. Therefore, my solutions are x equals -1 and -4. Now, -4, 5 we've already got. So therefore, the x value of the second intersection is -1. Plug it into this guy. 3 times -1 minus 7. -3 times -1 is positive 3 minus 7 equals -4. So the y value is -4. So my coordinate, like I predicted, is -1, -4. And that's it. That should definitely be correct. Boom! It is correct. All right, so that is it for the weekly Wednesday live stream from Scalar Learning. Again, if you like what you saw and you found this helpful and you are prepping for an upcoming SAT, please subscribe so you can do your best preparation possible. And if you like this video and you found it helpful, make sure to click the like button. It helps out the channel massively. Last but not least, leave a comment as well if you have a question or need clarification on anything that I did this morning. That's it for today. Have an amazing day, and I'll see you guys next time. Take it easy.